Hi, welcome to today's lesson. What we're going to be looking at today is solving simultaneous equations. Alright, so simultaneous equations. Okay, now with simultaneous equations, the thing you have to realize is that if I've got two variables, I need at least two equations to solve for it. When you get more advanced, you'll be looking at solving for three variable simultaneous equations, in which case then you need at least three equations to solve that. Okay, but let's just start easy. Let's start with two variable simultaneous equations. Okay, so let's look at this one, e.g. Solve 2x plus y equals 4, and I'm going to write this underneath, lining up the variables. X minus y equals 5. Okay, now the reason why I write them underneath, lining up the variables, is because the method that I'm going to be using to solve linear simultaneous equations, okay, is the method of cancelling. Now, you can do substitution, where if I get everything in terms of, for example, x here, if I did the opposite of minus y is plus y, and then I took 5 plus y and put it in for x there, I can do that and then solve for x. But the cancelling method is so straightforward and so easy. It's just easier to do that one every time. Okay. So the cancelling method says, I find a variable that has the same coefficient. Coefficient is the number in front of the variable. Okay, so it has the same numerical coefficient. Now if I look here, the x has got a 2 and there's an invisible 1 there. Alright, remember if there's no number, there's always an invisible 1 you can put there. The y has a 1 and an invisible negative 1. Well, all that I'm looking for is a coefficient that has the same numerical value, absolute value I should say, if you want to be really technical. So the 1 and the 1 works perfectly for me. So this is 1y and this is minus 1y. So when I'm doing this, I'm going to try to get rid of the y's. Now, here's the thing. If I've got positive 1 and negative 1, what I want to do to make them cancel out, okay? If I've got positive 1 and negative 1, in order to get 0, so to get nothing there, so the y's disappear, you with me? I want to put them together. If I have negative 1 and negative 1, then in order to get 0, I want to take them away from each other. Okay? When you understand integers, it makes a lot of sense. Alright, so if I want to put them together, oh, it doesn't rub out too nicely. No worries. If I want to put them together, then I'm going to add. Right, I'm going to add the columns. So take a look at this. If I add the x's, 2x plus x is 3x. 1y plus negative 1y, no y's. 0 y's, they disappear, right? And then 4 plus 5 is 9. Alright, and now we're just here with a linear equation with one variable. So it's easy to solve. Opposite times by 3 is divide by 3. X equals 9 divided by 3, x equals 3. Alright, so there's x. Now all I have to do is find y. Alright? You could put it back into either of these. Let's put it back into that one. 2x plus y equals 4. So 2, now I'm going to replace x here, x, plus y equals 4. So I'll put it back into this one. Okay? Alright, and now we only work it out. Well, 2x. What is x? X is 3. Are you with me? So I've just put that 3 in there. Okay, so let's tidy things up. 2 times 3 is 6, plus y equals 4. Opposite of plus 6 is minus 6. Y equals 4 minus 6. Y equals negative 2. And that's it. We are done. There's our two options. X equals 3, y equals negative 2. Okay. Now, you've got to go check with your teacher whether they want you to write it as two possible solutions, right? If I've got A's and B's, and this is what I do, or possibly as a coordinate, if you look at where these two straight lines, they're both linear, intersect. They'll intersect at x equals 3 and y equals negative 2. Alrighty. Now, I want to show you another one where this will lead on to the trick. Well, not trick, but a short alliteration that I tell my kids so that they remember it. Okay, so let's look at another e.g. 2. Okay, look at 3x plus 2y. 3x plus 2y equals 12. All right, and then x plus 2y equals 8. Alright, now you should be looking at this and from the previous one saying to yourself, okay, so, well, which ones do I want to get rid of? I want to get rid of the variable that has the same numerical coefficient. Meaning, I want to get rid of the variable with the same number in front. So, the 3 and the 1, x's are not going to go. Now, don't always get caught up with using the y's. In these two examples, I've got y's are the ones that are going to cancel. But sometimes it's the x's. Doesn't make a difference. Okay. But in this case, the 2 and the 2, these two are going to go. Now, here's the thinking again. If I've got positive 2 and I've got positive 2, how do I make that 0? I subtract them from each other. Okay? 2 minus positive 2, nothing, 0. So then the y's will go. So that's what I'm going to do here. I'm going to now subtract the two columns. Okay? So let's do this. 3x minus x is 2x. 2y minus 2y, no y's. They go, 0y. 12 minus 8 is 4. Opposite times by 2 is divide by 2. X equals 4 divided by 2 is 2. Okay, I'm speeding this up a bit because you get the hang of this, huh? And now I'm going to take this and I'm going to put it into that one. Why not? Okay, so I've got here, this is x, right? So 2 plus 2y equals 8. So I put it into this one. Okay, you could put it into the top one. It doesn't make a difference. All right, so I've got opposite plus 2 is minus 2. 2y equals 8 minus 2. 2y equals 6. Opposite times by 2 is divide by 2. Y equals 6 divided by 2 is 3. And we are D-U-double-N. Done. Okay, so here's my little tip for how to remember it. I tell my kids that if you look for the one that you want to get rid of, if the signs are the same, I subtract. That's a nice alliteration. Okay, so if the signs are the same, I subtract. If the signs are the same, I subtract. Okay, for two linear simultaneous equations. Okay, so if the signs are the same, I subtract. Okay, and this is intuitive because if you know this one, then if the signs are different, I should infer add. Right, I should add. But this one is an awkward one to learn, so I just learned the alliteration. If the signs are the same, I subtract. Okay, alright. So, that's what we do. If the signs are the same, I subtract the columns, get rid of one of the variable, out pops the other one. Alrighty. Okay, go take a look at this. In the next video, I'm going to be looking at solving simultaneous equations where there aren't any matching coefficients. There's a small extra step you have to do, but it's not too tricky. Okay, go and take a look at that, and remember, I'm here for you.